Hello, Acute Angels. This is Teacher Anna, and welcome to another Math Unique episode. Today, we will talk about combination. Are you ready? Well, at the end of this lesson, you are expected to illustrate the combination of objects, differentiates permutation from combination of n objects taken R at a time, and solves problems involving permutations and combinations. So what do we mean by combination? Combination is a mathematical technique that determines the number of possible arrangements in a collection of items where the order of the selection does not matter. In other words, a combination is an arrangement of objects wherein the order is not important. Let's consider this example. The BSN's Math Club is entitled to send 2 contestants to a local math contest. In how many ways could the choice be made from among the best competitors, Anna, Ella, and Ross? In the given problem, there are 6 possible permutations of the 3 contestants. Using an illustration, the first arrangement could be like this: Anna and Ella. For the next one, we have Ella and Anna. We also have Ross and Ella, or it can be Ella and Ross, Anna and Ross, and lastly, Ross and Anna. But since the order doesn't matter because we are choosing 2 contestants to be sent in a contest, we're going to eliminate pairs with duplicate. We will just count them as 1. Like this one. Anna and Ella is the same with Ella and Anna. We will consider them as 1. Ross and Ella is also similar to Ella and Ross, while Anna and Ross is the same with Ross and Anna. By counting, the BSN's Math Club could create 3 choices. Have you noticed the difference now? When we say combination, the order doesn't matter. In other words, the arrangement of objects is not important. ABC is similar to CBA, while in permutation, the order does matter. In other words, the arrangement of objects is important. To put it simply, ABC is different from CBA. Now, let us see some real-life examples. Then we're going to identify if it is an example of a combination or a permutation. Are you ready? The first one is Facebook password. Is it a combination or a permutation? Well, let's say your password is 1, 2, 3, 4, 5, 6. If we rearrange them like 6, 5, 4, 3, 2, 1, what do you think will happen? Does your Facebook will be like in? Definitely not, because it must be the same with 1, 2, 3, 4, 5, 6. Therefore, if the order is important, Facebook password is considered as permutation. Next example, we have to choose 3 of your classmates to attend your party. Is it a combination or a permutation? Let's dig deeper on this thought. As mentioned, you will only choose 3 with no specific criteria like who is best in school, who will perform better. It's like you are randomly choosing 3. And since there is no important order or rank, this one is an example of combination. Third example, we have fruit salad. Is it a combination or a permutation? Let us say your fruit salad includes apples, strawberries, and cherries. But what if we rearrange the order, like cherries, apples, and strawberries? Is it still the same fruit salad? Correct. We still have the same fruit salad. Therefore, In here, the arrangement is not important. So in this example, we have a combination. For the part 1, we have assembling a jigsaw puzzle. Is it a permutation or combination? To complete the puzzle, you must follow a certain order. Therefore, this is an example of a permutation. Lastly, picking 6 balls from a basket of 12 balls. Is it a combination or a permutation? Well, it is only mentioned that we will pick 6 balls without any rules. Therefore, we won't follow a certain order. So we considered it as a combination. Now that we have learned the difference of the two, let us now focus on how do we calculate the number of combinations. Just like a permutation, we also have a combination formula. This is for the number of combinations of n things taken r at a time. Anyway, we can use any of the three to represent combination. C with the quantity n and r, and cr, or C with a superscript n and a subscript r. The formula that we're going to use is the combination of n objects taken r at a time is equal to n factorial over the quantity n minus r factorial multiplied to r factorial. Does it look familiar? Well, it is somehow similar to the permutation formula, but the only difference is that we multiplied the r factorial to the denominator of the permutation formula. C with the quantity n and r is the number of combinations, where n is the total number of objects in the set, and r is the number of choosing objects from the set. And again, the value of r is less than or equal to the value of n. Let us try evaluating this one using the combination formula. Evaluate the combination of 7 objects taken 2 at a time. The given value of n is 7, while the value of r is 2. And as mentioned, we're going to use this formula. Now, substituting the values of n and r to the formula, we have 7 factorial over the quantity 7 minus 2 factorial multiplied to 2 factorial. 7 minus 2 is equal to 5. Then 7 factorial means 7 times 6 times 5 times 4 times 3 times 2 times 1. And 5 factorial is equal to 5 times 4 times 3 times 2 times 1. And 2 factorial is equal to 2 times 1. And as you can see, we have similar terms which we can eliminate. So we cancelled out 5 times 4 times 3 times 2 times 1. Now we only have 7 times 6 all over 2, 2 times 1. 7 times 6 is 42, and 2 times 1 is 2. So we have 42 over 2, which is equal to 21. Therefore, the total number of combination of 7 objects taken 2 at a time is 21. Let's have another example. This time, we have a word problem. In how many ways can a coach choose 3 swimmers from among 5 swimmers? Let's identify the given first. The value of n in the given problem is 5 because of the 5 swimmers. And r is 3 because from 5 swimmers, we will only choose 3. Again, we will use this formula, and substituting the values of n and r to the formula, we have 5 factorial over the quantity 5 minus 3 factorial multiplied to 3 factorial. 5 minus 3 is equal to 2. 5 factorial means 5 times 4 times 3 times 2 times 1, while 2 factorial means 2 times 1, and 3 factorial is 3 times 2 times 1. And as you can see, we have similar terms that can be eliminated. So we cancelled out 3 times 2 times 1. The remaining terms now is 5 times 4 all over 2 times 1. 5 times 4 is 20, and 2 times 1 is equal to 2. We now have 20 over 2, and 20 over 2 is equal to 10. Therefore, the coach can choose 3 from 5 swimmers in 10 ways. Now, let's work on this problem. How many chess games can be made in a group of 6 players? Of course, we are going to identify the given first. The value of n is equal to 6 because of the 6 players. But what about the value of r? Well, as we analyze the problem, it talks about chess games. And in chess games, we only need 2 players every game. So the value of r is 2. And again, we will use the combination formula. Substituting the values of n and r to the formula, we have 6 factorial over the quantity 6 minus 2 factorial multiplied to 2 factorial. 6 minus 2 is 4. And 6 factorial means 6 times 5 times 4 times 3 times 2 times 1. And 4 factorial is equal to 4 times 3 times 2 times 1. While 2 factorial is 2 times 1. And again, we have similar terms which we can cancel out. We eliminate 4 times 3 times 2 times 1. The remaining terms that we have now is 6 times 5 all over 2 times 1. 6 times 5 is 30, and 2 times 1 is 2. 30 over 2 is equal to 15. Therefore, 15 chess games can be made in a group of 6 players. And now that we already learned how to solve combination word problems, let us dig deeper on how do we determine if a given problem is permutation or combination. Aside from identifying if the order is important or not, we can take note of the following keywords so that we can easily determine if the given word problem is all about permutation or combination. For permutation, we have these keywords: arrangement, ordered, unique, and rank. For combination, we have the following: select, choose, pick, and combination. But what if there is no keyword clearly shown in a problem? Well, we need to visualize it, like you are analyzing the problem thoroughly, to identify if it is a permutation or a combination. Let's see some examples. A local school board with 8 people needs to form a committee with 3 people. How many ways can this committee be formed? First, let us identify if the given problem is all about permutation or combination. Let's analyze it. As mentioned, there are 8 people to be taken 3 at a time. Therefore, we have 8 as the value of n and 3 as the value of r. Also, we want to know how many ways this committee can be formed. It only mentioned committee and not a specific rank or responsibilities. Therefore, the arrangement is not important, so we will use the combination formula. Substituting the values of n and r to the formula, we have 8 factorial over the quantity 8 minus 3 factorial multiplied to 3 factorial. 8 minus 3 is equal to 5. Now, we will evaluate the following factorial. 8 factorial means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 5 factorial is 5 times 4 times 3 times 2 times 1. And 3 factorial is 3 times 2 times 1. And as you notice, we have similar terms which we can eliminate. We cancelled out 5 times 4 times 3 times 2 times 1. The remaining terms that we have now is 8 times 7 times 6 all over 3 times 2 times 1. 8 times 7 times 6 is equal to 336. And 3 times 2 times 1 is 6. So we have 336 over 6, which is equal to 56. Therefore, there are 56 ways to form the committee with 3 people. Another example, a local school board with 8 people needs to form a committee with 3 different responsibilities. How many ways can this committee be formed? First, let us identify if the problem is all about permutation or combination. Let's analyze the given problem. As mentioned, there are 8 people to be taken 3 at a time. Therefore, we have 8 as the value of n and 3 as the value of r. Also, we want to know how many ways this committee can be formed with 3 different responsibilities. As stated, they will have different responsibilities. Therefore, the order is important, so we will use the permutation formula. Now, substituting those values to the formula, we have 8 factorial over the quantity 8 minus 3 factorial. 8 minus 3 is 5, and 8 factorial means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. While 5 factorial means 5 times 4 times 3 times 2 times 1. And as you can see, we have similar terms which we can eliminate. We cancelled out 5 times 4 times 3 times 2 times 1. The remaining terms now is 8 times 7 times 6, and 8 times 7 times 6 is equal to 336. Therefore, there are 336 ways to form the committee with 3 people. The next problem is, in a group of 10 people, a 1,000 pesos, 500 pesos, 200 pesos, and 100 pesos prize will be given. How many ways can prizes be distributed? First, let us identify if the given problem is all about permutation or combination. Let's analyze the given problem. As mentioned, 4 prizes will be given. There are 10 people to be chosen to receive the prize. Therefore, the value of n is 10, while the value of r is 4. And since the prizes are different, we will use the permutation formula, because if you are the first winner, you will receive the highest amount. That is why the order is important. Substituting the values of n and r to the formula, we have 10 factorial over the quantity 10 minus 4 factorial. 10 minus 4 is 6, then 10 factorial means 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. And since we have similar terms, we will eliminate them. We canceled out 6 times 5 times 4 times 3 times 2 times 1. The remaining terms that we have now is 10 times 9 times 8 times 7, which is equal to 5,040. Therefore, the prices can be distributed in 5,040 ways. And for our last example, in a group of 11 people, 500 peso bill price will be given. How many ways can prices be distributed? First, let us identify if the given problem is all about permutation or combination. Let's analyze it. As mentioned, there are 11 people and 5 will be chosen to have 500 pesos. Therefore, the value of N is 11 and the value of R is 5. Also, we want to know how many ways can prices be distributed. And since the prices are the same, it is not important if you come as the first winner or the second winner because you will receive the same amount, which is 500 pesos. So in here, the order is not important. So we will use the combination formula. Now, we're going to substitute the values of N and R to the formula. We have 11 factorial over the quantity 11 minus 5 factorial multiplied to 5 factorial. 11 minus 5 is equal to 6. Then we're going to evaluate the following factorial notation. 11 factorial means 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 6 factorial means 6 times 5 times 4 times 3 times 2 times 1. 5 factorial means 5 times 4 times 3 times 2 times 1. And since we have similar terms that can be eliminated, we will cancel them out. We canceled out 6 times 5 times 4 times 3 times 2 times 1. The remaining terms now in the numerator is 11 times 10 times 9 times 8 times 7, which is equal to 55,440. And for the denominator, we have 5 times 4 times 3 times 2 times 1, which is equal to 120. We now have 55,440 divided by 120, which is equal to 462. Therefore, the prices can be distributed in 462 ways. And that's it. Just remember that in combination, we don't care about the order, which is quite different for permutation, because in permutation, we do care about the order. Dear Acute Angels, you did great in watching and listening. I hope you are now confident to answer activities related to it. Again, this is Teacher Anna, and see you on another Matinique episode.